try to upload it to the website. Okay.
All right. So as Julie said, I'm Kathy Kellenberger, and this is such a really cool night for me because I've had a group of people that I've been teaching all day long, and a couple of them actually didn't get enough of me, and they're here tonight. So, and the other really cool thing is that if you guys have not heard of Launch Code and Coder Girls in St. Louis, this is the birthplace of a revolution in St. Louis right now. A gentleman, was it Jim McKelvey? Is that his name?
Oh, yeah, James.
Yeah, so he was the inventor, or he was the guy who thought of Square, which is a little thing you can hook on a cell phone to take MasterCard and Visa. You know, he came up with that idea, but he couldn't find any developers in St. Louis. And so what he did was went out to Silicon Valley to get developers to create this product. And then he said, hey, so this guy's a problem solver. How do I solve this problem? Why can't I find enough developers in St. Louis? So he started a nonprofit organization in St. Louis called called Launch Code. Lynch is something else. Lynchpin, Launch Code. Okay. It's called Launch Code. And it's basically, some of you, probably Scott Trade and some of the other organizations that some of you work for are probably part of Launch Code, partnering with Launch Code. And basically what happens, Launch Code helps get people trained. They test them and say, you're ready to get a job, but maybe you don't have experience. So they will partner with these companies and get these people internships. They're paid internships, $15 an hour, and they get hired. A lot of times, a few months later, after this internship, maybe they'll get hired at MasterCard or some of these other companies. So I have seen person after person get these internships and get hired. So a couple of years, actually about last year, they decided there were not enough women in the group, and so they decided to start a separate organization called the Coder Girls. Not really separate, but kind of an umbrella, kind of a subgroup, Coder Girls. And so I'm part of that. On Wednesday nights, I go and volunteer, and I'm helping a group of women with learning SQL Server. So if you would like to be a mentor they need people to mentor. They need people to be speakers. I mean, and it is exciting. This is like, it's hard to describe. And I'm really, really happy because some of my Coder Girls are here tonight, and let's applaud them. Yay, Coder Girls. So there's one, and there's one, and there's one. Are you a Coder Girl too?
I was your student at SLU.
You were my student at SLU. So you didn't have enough of me either. Okay, so this is just awesome. Huh?
Always Wednesday nights.
Coder Girls is always Wednesday nights. But they're looking for, I don't know about how the regular Launch Code works with mentors, but they probably need mentors as well. I don't know what time they meet. So it's just amazing. About 100 Coder Girls show up on Wednesday nights ready to learn. It's amazing. And so I'm really thrilled. So Julie asked me to speak tonight, and I just looked at my calendar and said, oh yeah, I'm free. Well, guess what? My daughter had a baby this morning.
Why are you here?
I don't know. I don't know why I'm here. My daughter had a baby this morning. This is baby Nate. He was born this morning. So when I looked at my calendar, I didn't mark down baby due date. So today was his actual due date. She went in the hospital yesterday. So then, at the last regular user group meeting, I told you this. I'm really dedicated because that's my grandson's due date, and she said, "Oh well, let's get someone else." I said, "No, I can do it. He'll be born early. Don't worry." Well, he wasn't. But anyway, that's my excitement today. So I'm really, really thrilled about having people that have listened to me all day long, people that listened to me when I was teaching at SLU, and my Coder Girls. So it's really, really a fun night for me. So let's talk about indexes. Or I could talk about grandkids. Whatever. I have 5 now.
Indexes are easier.
Indexes. You don't have grandkids yet. You don't know. And grandkids are fun. No, he's not your grandkid though. He's your son, but he's not your grandson. Grandchildren are much easier than children. Trust me. Okay, so what we're going to talk about today, or this is going to just kind of assume that you don't know what an index is. We're going to talk about the basics. I have a mix of experience levels in this room. I have, seasoned DBAs, I've got seasoned developers, and I have people that are just starting out. So this is going to be really the basics. I hope everybody will learn something. Okay? So in SQL Server, good things come in small packages. And what I mean by that is that imagine if I have a table with 50 million rows compared to 5 rows, it's a lot less work for SQL Server to work with a small amount of data, right? Okay. Same thing with indexes. We can make an index smaller and we can get SQL Server to read that index instead of reading a whole table, SQL Server is going to be more effective. So really that's where that comes in. And I forgot to bring my props. I usually bring a phone book, and I completely forgot. It's too much excitement this week. I usually talk about, so for example, if I have a book, like one of those books over there that has an index in the back, that index is small compared to the text of the book. So usually your indexes are smaller, and we like them to not be too large. We want to make them really, really efficient. All right. So let's first start talking about tables, just tables themselves. There's basically two kinds of tables I can have, and this is just the basics. We're not going to talk about lots of the new stuff like XML or file table or any of that. We'll just talk about your basic tables. There's two kinds. One is called a heap. The other is actually called a clustered index, but the structure of it is called a B tree or balanced tree. So when I think about a heap, what that means is this table is just unorganized. I have columns and I might have constraints, but the way it's laid out and the way it's organized row to row is unorganized. So imagine that you have a nice, basket of laundry. This laundry is clean. It's just came out of the clothes dryer, and it's very nice and warm and smells really good. Okay? Imagine that I needed to find, how do the colors look there? Okay, good. Imagine that I needed to find all the yellow, pink, polka-dotted socks. How would I find those socks? I would have to pull each thing out, right, and look at each thing. All right, so that's really what a heap is. We'll talk more about other kinds of indexes heaps can have. But basically, that heap is like that basket of laundry. There's no organization to it. If I need to find something, I've got to look through the whole basket to find the items I'm looking for. The other kind of table, usually we call it I changed this title. I originally said 2 types of structures. And then I said, oh no, 2 types of tables. So maybe I should have left it structures. The other kind of table is actually organized as an index. And that's called a clustered index. Okay, so if you hear the term clustered index, and this applies to SQL Server. So I know I have at least one DB2. Is that what you work with? One DB2 person here. I have no idea what DB2 does. So in SQL Server, we have a thing called a clustered index, and what that means is is how my table is organized. So imagine that I take that laundry and I fold it up and I put it in a nice, chest of drawers or whatever you want to call it, dresser, and I have an absolute perfect spot for those yellow, pink, polka-dotted socks that they go in. So I have a place for T-shirts. Everything is organized. So now I've got that same basket of laundry, but now I've organized it so everything is in a certain spot. Everything's easy to find. Now if I want to find those socks, I know exactly where to go. Okay? So this is also called a balanced tree or a B tree. I used to think it was called binary tree, but it's really not. It's balanced tree. Okay, so if I have a heap, all these examples are very simplistic. Don't think that under the covers this is what they really look like. I've just got a very, very simplistic representation. So imagine that I have a heap and I have these letters. Each row is a letter. Normally we have data in pages, but for this simple example, let's just work with the letter. And I need to find the letter A. How do I find it? I look at the first one. Is that an A? No, it's not. Look at the second one. That's not an A. Look at the third one. Look at the fourth one. Oh, great. I finally found the A. Okay, so that's how things are lined up. They are lined up in order of the way that the data was inserted. So that's a heap. I also could have a B tree, and a B tree looks something like this. In real life, I have a fraction of those pointers. Those arrows are pointers. I have a fraction of the pointers that are actually in a B tree. They're going all over the place to make things efficient. But the thing about a B tree, or a clustered index, any kind of non-clustered or clustered index, is that I kind of have, up at the top, I kind of have the middle of the data, and when I search it, I don't have to search through every single thing. So if I want to find that A, I start at the top, and now I ask myself, do I need to go left or right? Okay, so A is less than M, so let's go left. And A is less than D, so let's go left again. And now I found it. So I had a lot less data to look at to find it when I have this data in a clustered index. All right, so what I want to do is play a little game. And I have I have a table that is a heap. And don't worry about what this code does. Don't worry about writing it down because I'm not going to cover it, and I don't really care if you understand it or not. But basically, I'm going to guess, I'm going to come up with a random number between 1 and 1,000. That's what this little formula does. And then I'm going to look through my table. Hopefully I've got this right. Sometimes I have it the wrong field pulled. From this table called heap. Actually, I'm in the wrong database. There we go. And keep looking until I find it. So let's go ahead and let it run. So my number was 61. And so it started at the first row of the table and just kept going until it found it. So it's printed out the things it looked for. It did take a while to run, didn't it? Let's go all the way down to the bottom. Wow, it really took a while. It took 703 guesses to find that 61. So I had to keep looking through every value. So let me try that again. Maybe that was a fluke. Oh, a cursor with the name. Oh, I do not have a closed cursor at the end. I didn't have it selected. Aha. Oh, this is really bad code because I don't even have my semicolons. I had a whole discussion today with the class I was teaching about how I'm so good about putting those semicolons on. Not always, evidently. Okay, I try to be good. I try to get those semicolons in there. 841. And let's hopefully, this time, it took really about the same, 717. Okay, enough of that. Well, let's close this one. Now, let's find the number in an index. In this case, I cheated a little bit. All I'm doing is I start, the same kind of idea. I have wow, should I start with 1,000,000 here? Let's start with 10,000. And basically, this is how an index works. I find the middle of the data, and I keep going high or low until I find the answer. So I really didn't even have to have a real table. I'm just going to calculate, pretend like there's a table and calculate it. So let's see what happens. My number is 5496, and it found it in 14. Wow, maybe that was just lucky. Maybe that was lucky. Let's do that again. 10 guesses, even luckier. What?
The schema. We're going to change the schema.
You're going to change the schema?
It's in master.
It doesn't matter. This one I'm just doing it all in memory.
Okay.
This particular one. I don't really have a table. I'm just saying, pretend I have a list of numbers, and I'm just going in the middle and going in the middle and going in the middle. Okay, so let's change this number here. Let's change it. Let's add a couple zeros. Is that 1,000,000? Let's see what happens. Okay, that's the number we were searching for. Took 19 guesses. Looking through 1,000,000 numbers, I touched 19 numbers to find the one I was looking for. So this is not exactly, 100% accurate demo of an index. An index actually works better than this. But you get the idea. This one, 20 guesses. And there is a formula, and I never remember. It's got something to do with logarithms and things like that I've forgotten about many years ago, decades ago. 19 guesses. So that just shows you the power of indexes. Okay? In other words, I don't have to look at every single thing. I can jump down the path. Okay? Let's close that one out. So this is kind of what a clustered index looks like. It's kind of like an upside down tree. At the very top of it is the root, and at the very bottom of it are the leaves. So it's like a tree, but it's kind of flipped over. I've seen some speakers go ahead and do it the other way, so it matches a real tree outside. I can't get myself to do that. I have to do it this way. After taking those CS classes at SIU, I can't do it the other way. So at the very top, so when I have my index, I like to think about a phone book. And I usually try to bring a phone. I should just keep a phone book in my laptop bag because I speak on this so much. Anybody remember what a phone book is? You remember those? Have anybody used one recently? No. My husband will pick it up off the porch, put it in this certain, cabinet, take the old one out, put it in the recycle bin. He would save time if he just went straight to the recycle bin, right? Okay, a phone book is a clustered index. Forget the businesses. Let's just think about people. Imagine that there's just people in there. There are keys. An index has keys. How do I want to organize this index? I don't pick everything. I pick just a couple of keys. How do I want this data organized? So a phone book is organized by last name and first name. Okay, so up in the top of my index, and these non-leaf levels, I have just last name, first name. In the bottom of it, I've got we also have an, I don't know how they do it if you have two people with the same name. Then they probably look at city. I don't know how they do it. But in the bottom of it, in the leaf level, that's where I have everything. I have those key columns repeated, plus I have their phone number, whatever else it was. When I was a kid, we had this really cool book called a city directory. We called it the gossip book or the snoop book. I don't know. Because it had in there, not only did it have the names and address and the phone number, but it also had where the dad worked and if the mom had a job, where she worked and the kids and their ages and stuff. It was really great. It was fun. But anyway, if I had that city directory, all that extra information about the kids and where they worked and everything, that'd be in that bottom leaf level. So when I have and remember what I said a few minutes ago, this is actually my table. This is how my table's organized. Okay? The problem is sometimes physically things get out of whack. That's called fragmentation. If I add new rows or I make changes, sometimes things get fragmented. And there's ways that the DBA takes care of that. They have jobs that they run at night or on the weekends or whatever to fix the index. So even if the index is fragmented, logically, are you guys laughing over there at me? I'm like, okay, there's probably these DBAs with 20 years experience laughing at me up here. So even if the index is fragmented, things are not where they need to go, there's pointers that logically connect things. So logically, it's still organized, even if it's not physically organized. And that's why DBAs run that job to fix the indexes, periodically, because otherwise queries start getting slow if we expect the data to be, lined up, and all of a sudden now we've got to jump from over here to over here to over here, then that's going to slow the queries down. So that's why DBAs have that job in place. So that's what a cluster index kind of looks like. Okay? So there's a lot of rules about cluster. There's a whole I'm going to say all kinds of controversies. People arguing about what a clustered index should, what you should choose for your cluster key. Should you even have a clustered index? There's people arguing about that. What?
It depends.
Huh?
It depends.
It depends. Yes, it depends. People are always arguing whether or not you should have one. Most of the time, you should in SQL Server. Now, I understand that in Oracle, they don't. I don't know. Someone is saying, because in my tech editor of that Windows function book, that was the main thing he said to me was, we don't have clustered indexes in Oracle. Did you see that same thing when you?
I got a few other comments from him that I was scratching my head at too, and I know Oracle as well.
I don't know Oracle. I've run select queries against it. Really don't know it. But this is my co-author back here.
So Clayton is
Clayton.
the other co-chair of the BI use group.
Yeah. So when we give the book away, you can get autographs from both of us. So, but anyway, there's a lot of controversy. So what I'm going to do is I'm going to go through and tell you what some people say are best practices, but somebody else is going to argue about how to design that key. Okay? How do we want this? What's the best way to organize this data? Probably 90% of the time, it's based on the primary key. Because if I don't do anything else, if I just say assign a primary key, I end up with a clustered index that matches it. By default, that's the behavior. But we don't have to do that. So, and then again, they talk about data types. So here's one recommendation. However, people argue about it. Because there really is the best key is ever increasing. The reason for that is that you have less fragmentation. If I start adding rows and we're going to have like it's an ID number, and that ID number keeps increasing, and that cuts down on fragmentation. However, somebody else is going to argue with me, well, guess what? Now you've got a hotspot in the latest page, the page where everything's getting inserted. Now that's a hotspot. So you shouldn't do that. So I don't know. I don't know it probably depends on the situation. I really haven't had a problem with hotspots, but I have seen lots of problems with fragmentation. I haven't really seen the hotspot problem. The people argue about that. So some people will stand over here and say it needs to be an incrementing ID number. Somebody over here will say it needs to be a random GUID. It depends. I've worked with a system that used GUIDs, but they made them in order. They figured out how to order them. So they had both things. They had the hotspot and they had a big fragmentation mess. And they did come up with a way to fix it. So anyway, if I have data that's inserted and I'm not inserting it in order of the cluster key, what happens is I have to have pointers pointing to the next row. So let's see, I can't remember how this thing goes. So like M points to S points to X, D points to M. And if I keep adding things, then I have to keep changing things around. And that's where this fragmentation comes in. So if I didn't have an ever-increasing key, I automatically get fragmentation. So this customer, so in this table, my primary key, I'm inserting rows, but then there's other tables where the primary key is something different, and they're using GUIDs. Well, they were having problems where they were having to rebuild indexes. They were rebuilding them at 6 in the morning. By 10 in the morning, they were having to rebuild them again because there's fragmentation problems. Well, they ended up, this was before I worked for them, they ended up changing the fill factor and to 90%, and that solved that problem. So it just kind of depends on what's going on. It was a mess, evidently, before I was there. All right, so I think most people would kind of agree with this. The best cluster key is narrow and unique. That's kind of two things, isn't it? Narrow because I haven't talked about non-clustered indexes yet, but when I talk about non-clustered indexes, guess what? That cluster key is part of that non-clustered index that we'll talk about later. So it's going to make other indexes smaller. Okay? It's going to be, remember I said at the beginning, good things come in small packages. It's going to be more efficient to have a small key. Unique because why would it be, I don't know how to really explain unique. So I guess so you don't want to cluster, let's say it this way. Let's say I had a column that was was a bit column that could be 1 or 0. I would not want that to be my cluster key. Okay? Because I'm going to have everything, I'm going to have just 2 groups. It's going to be really inefficient, really, really inefficient. So to go on the other end of the spectrum, I would like that key to be unique. And most of the time it is, because most of the time it's the primary key. So we want it to have the most possible unique values in it. All right, I think most people agree with this one. The best cluster key is static. We don't want to make changes because guess what? That's going to cause fragmentation. If I change the value of my cluster key, now all of a sudden that row is in the wrong place. That's going to cause fragmentation. So let's just take a look at a few examples. Some of these examples are kind of contrived, and I understand that, but just go along with me. Just humor me. Remember, it's my day. It is. So, all right, so I'm going to create a table called random inserts. And I specifically chose this particular definition because I wanted this row, I wanted every row to fill up a page. I believe that's why I chose this definition. So this particular column, even though I'm filling in just AAA, it's a care 896, so it's going to take up 896 spaces. So I played around till I got something. There's already, okay. I guess that's why I probably wanted to do this. I ran everything like today at lunch and before the meeting to make sure it would work. All right, so now I'm going to create a clustered index on that, and I'm creating it on the ID column, so I'm actually doing it later. You can do that. It doesn't have to be the primary key. And then I'm going to run this loop, and what I'm doing is I am going to insert random values into this table. I think it'll only take about 10 seconds to run. Hopefully not longer than that. But do you guys want to see a picture of my baby again? While it's running. So it's probably taking longer because I'm recording, and whenever I did, 14. Okay, not too bad. All right, so now I have this table with random data in it. And here's another one. Now this one, I'm going to just insert data, but it's going to go in order. Okay, same table definition, except it's in order. I don't think I have that non-clustered index, though. I wonder what's up with that. Or that clustered index. I left that out. Okay, so if I look at this, I should get back data. And even though the first one I inserted randomly, since there is a clustered index by ID, it's easy for SQL Server to return it in the logical order. That's why it's doing that. And this one also, that's the order it was in. That's the one that was actually entered that way. This one it was entered randomly, but it's easy for SQL Server to return it in the order of the clustered index because that's the order in which it's sitting. It doesn't have to do any sorting. Okay, so this particular query here, this is one of the called a DMV or DMO. It's one of the many tools that Microsoft gives us. Is these metadata queries, okay? Metadata objects, where we can look at things under the hood. What's going on under the hood? Well, this particular one will give me a picture of the index. So let's go, not really a picture, but it'll show me what's going on with the index. So let's take a look at both of these and see the difference. So the very first one, this one, let's see, how do I prove that? This was the random insert one. Here's the fragmentation of that index. Notice that it's 99% fragmented. That's really bad. It's completely disorganized. It's organized, but physically it's disorganized. Logically, it still is. And it's got, here's another thing that it's telling me. We would like the number of pages to be small, if possible. And It has more pages. It still has the same number of levels, and of course it's got the same number of records overall. This very top row here is the leaf level. This is the very bottom, and these other two are non-leaf. So SQL Server is super, super efficient. I don't understand everything under the hood, but it's only, somehow it can find, it can make an index in just 3 levels. When I did my little one on the slide, I had like 4 or 5 levels. So this tells me, notice that the other index, which is the, that I entered in order, notice that the fragmentation here is less than 50%. Or not less than, less than 1%. I'm sorry, less than 1%. So that index is in really nice shape. Okay, so the other thing I talked about is that we would like the index to be narrow, so it's more efficient. So let's go ahead and run this. I've got a table called wide. I'm going to have a similar definition. I'm going to keep using the same definition, and I'm going to go ahead and enter those in order. So we've already looked at random. And do the same thing. Look at the fragmentation. Compare that wide table to our really nice table. Whoa, look at this guy. So he not only he's not terribly fragmented, moderately fragmented, but look at how many extra levels this guy took. And he's got a lot of extra pages. That's because that, let's see, the top of this one is the bottom, the leaf level, but that top part, the non-leaf level, is taking up a lot more room because I made it a wide key instead of a narrow key. Okay, so it's not going to be it's not going to be as efficient because it's a larger object. Where this guy is that one we looked at a minute ago, only has the 3 levels. Okay, so that's another reason. Plus, we'll talk about non-clustered indexes. Non-clustered index, that key is repeated as well. Here's one non-unique. So this one I think is a little more really contrived. All of these examples are really contrived, but they're just kind of to show a point. You're not going to have, something as random as I've got, or maybe as wide as I have, but just to show the differences. All right. So let's look at the fragmentation for non-unique. So when it's non-unique, again, the fragmentation is not too bad, but we've got lots of levels. Okay. And I wonder if this is really going to work that well. If I do a query on the non-unique and compare it to the others, and I'm going to use statistics.io to compare it. Statistics.io is one of my, so they all bring back one row, but in order to find a row in the non-unique, it actually, so what I really concentrate on, this is a query tuning thing, kind of really beyond this level of this talk, but just to show you, trust me. How many times have I said that so far? Logical reads, as somebody who tunes a lot of queries, I rarely get to write anything from scratch. People give me things to tune. That's my main business now. At the very bottom one, the order it inserts, it read 3 pages to come back with the answer. On the non-unique, depending on how I did it, I got back 1,500 or 321. So when I'm looking at this, the smaller number is bigger. So for those of you with a little more experience, you can agree with me that that's the case. Okay, so the best cluster key doesn't change. We're going to create a table, and we're going to insert the data in order. It's going to be a narrow key. And we're going to look at the fragmentation before. The fragmentation before, it's beautiful, everything's nice, everything's wonderful. And I'm going to update some of the rows. In fact, maybe I should run this a couple times. updating a few of the rows. Now I'm going to look at the fragmentation again, and now it's at 28%. Before it was like practically zero. So the fact that, not so much that I'm just doing updates, but the fact that I'm changing the cluster key. My cluster key is ID. That's my cluster key. The fact that I'm changing that, I'm causing that table to become fragmented, or creating pointers all over the place. Okay? Any questions about this? Really, the point of this was just kind of show you extreme examples of how fragmentation happens, and because of how the clustered index was designed. Okay? The index still works, especially if you're trying to find one row. It still works. But for some queries where you're aggregating a lot of data, once it's fragmented like that, that's going to slow those queries down. Okay? All right. Let's keep going then. So my buddy that I used to work with at Pragmatic Works wrote a book on indexes, and I've got the name of it at the end of the slides. He used this example of card catalogs at the library. Anybody see a card catalog at the library before? Recently? Now, I took my grandson Thomas last year to the library, and I went down to the kids area, and they had a card catalog, and I was thrilled. Because when I was a kid, none of you guys knew me then, but I was like really a nerd back then. You're like, oh yeah, she still is. I was really a nerd because I loved anything with data when I was a kid. I should have known I was going to be involved with data. Because I would go to those, I would just think of things to look up. I may not have even been interested in the book. I would just there was probably a line behind me, because I would say, oh, I wonder about this, I wonder about that, and I would be looking things up in those card catalogs. So my buddy Jason Straight came up, and maybe some other people did too, coming up with an idea of a non-clustered index, not only the index in the back of a book. If I have a book, I have all the information, and then I have in the very back, I have an index. Not all books, but like the books we're giving away tonight have indexes. That is a smaller structure. This is what I really love about this. When I look something up in that non-clustered index, a separate structure in the back, it tells me what page to go to. What happens when I use a non-clustered index in SQL Server? It tells me what page to go to. I love that. But anyway, I always use that analogy of the index in the back of the book, but then my buddy Jason had this one about the card catalog. So we're going to talk about, I'm going to talk about an author who has written a lot of books, Stephen King. Okay. I have an assignment. So this is 1970. Let's go back in time. Well, actually, he wasn't writing books in 70. Let's go back to 1980. He didn't have that many books then. But let's pretend like the card catalog is all we have. Let's do that. All right, so I have an assignment. How many books written by Stephen King are in this library? So guess what? I can go up to the card catalog and I can find the case. So there might be an index. There's multiple indexes. There's an index by author name. There's an index by subject matter. There's an index by title. I can't prove this, but there must have been, because I remember looking things up different ways. So I can look in the Ks. Anybody have a clue about why I won't find all the Stephen King books in the Ks? Anybody know? What? He wrote under two names. Richard Bachman is the other name he wrote under. Yes. It was kind of an experiment. He came up with this name just to see if his books would sell if it didn't have his name on it. And that lasted for a while, and somebody figured it out, and then guess what? Those books sold. So just his name on there sells books. Okay, so all I have to do is look in the author catalog and find his name and count those cards. I do not have to make a trip to the shelves. I have my answer in the index. Guess what? That's what we really love to happen. That's what when I'm query tuning, that's what I want, that's what I try to achieve, have all my data come from those non-clustered indexes. Okay, so now I have another question on my paper. What are the titles of these books? Guess what? I can look at that index and get a list of those titles. Okay, I can count, I can get a list. How many pages in each book? If I remember correctly, that was also on those index cards. So there's all those pieces of information, not all of them. So remember that structure I showed you. There's a thing in non-clustered indexes that I'll tell you about in a minute called included columns. So I can have extra pieces of information that I don't actually index. They're just part of the index, kind of like freebies for me. What if I needed to know the first sentence on page 42 of one particular book? I could find the location, and I would have to walk over and get that information. Okay, so I have a couple slides later, but the fact that I can, every time I ask a question and I can find the answer from an index, that's called a covering index. The index doesn't change, and I hate that terminology because it sounds like it's some special property of the index. It sounds like it's some kind of special characteristic, a little checkbox. Ooh, let's make this one covering. No, it's covering for this particular query. I can write another, that one where I want to find out that first paragraph on page 42 of some particular book. I got to go to the table to get that. Now it's non-covering. A minute ago it was covering. Now it's not covering. Okay? Does that make sense? So the reason I like these pictures is because I would say over the past, literally since September, since I've been independent, a lot of what I'm doing is looking at indexes and maybe suggesting, hey, let's add one more column here. There's definitely a science and an art to tuning queries, tuning indexes. So it depends on where you work. The group I'm working with this week are not allowed to change the indexes. But the group that I've been working with for several months, all I have to do is put in a request and say, hey, add this one column to this one index. And that query that's timing out will no longer time out. Okay? Because I don't have to. So here's the bad thing. If I had to look at the first paragraph on page 42 of 10 books, as a person, I would walk over to the shelves one time and write all that stuff down. But guess what SQL Server does? It makes one trip for every one of those books. Okay? So guess what? If I have 1 million, for some reason I need to find out a large number, sometimes it's more efficient for SQL to just give up and, kind of like, I'm just going to forget about this non-clustered index. I'm just going to scan that table. Because in this case, it's more efficient to do that. But it really is a science and an art. And, I had a customer that I worked with. Hopefully get some more work coming up with them. But they had, believe this or not, for those of you experienced people, 2005 on 32-bit on 10-year-old hardware. Like, SQL Server 2005, Windows 2003, 32-bit. They're having timeouts like crazy. And they're like, yeah, so the people laughing, they have experience. And they know, that's like, oh man, is SQL Server even run on that? So they could work, but they had timeouts. And they're creating their own software. So they can go in and change the timeout, because by default it's 30 seconds for this application. So on some of them, they've changed the timeout just to get these things to work. So luckily, I was able to go in there, and we added 3 new indexes, and we added some include columns to a couple more, and all their timeouts are done. Nothing's taking longer than 30 seconds. I was able to do that in just a couple of days, figure that out, and tell him what needed to be done. He did it, and amazing. We're still on 32-bit. We're still on SQL Server 2005 and Windows 2003. So I told him, you need to hopefully try to upgrade and maybe virtualize that. I've given him some advice about the future. But for now, I've solved his problems just because of my art and science abilities. So it's not something really that, I don't know, there's so much science to it because I can look at what's called a query plan. SQL Server tells me what's going on. SQL Server will tell me whether it's scanning an index or whether it's looking. It's called a seek, looking through that index. Tells me why it's doing what it's doing. Or well, it doesn't really tell me why. I can figure that out. And so then I can make a recommendation. Oh, look, it's got what's called a key lookup. So when I said go to the shelf to look at page 42, that's called a lookup. It's either called a key lookup or a RID lookup, depending on whether your table is a clustered index or a heap. So if I can just tell him, hey, it's going to the table just for this one little piece of information, why don't we add that to the index? All of a sudden, that query that was timing out runs in 1 second or 0 seconds. So it's pretty amazing. So it's really fun work. All right, so this is what a non-clustered index looks like. It may look familiar because it looks to me about like the screen. In fact, I probably did a copy and paste and then just changed some things. So a non-clustered index, and this is that index that's a separate object, looks a lot like a clustered index. However, where a clustered index was the table. Okay, trivia question. Experienced guys, keep your hands down. How many clustered indexes can I have clustered? How many clustered indexes can I have on a table? Any of the new people have a guess? How many clustered indexes used to organize the table? How many clustered indexes? You need to know this because this will be an interview job.
One.
Right. This will be a job interview question. I can guarantee it if you go into database work. How many clustered indexes? That would probably, unless I really felt that this person had potential and I knew they were really new, that might be my reason to stop the interview right then if they did not know that. Okay, so a clustered index is how my table is organized. A non-clustered index is actual indexes that are extra. Think about the books again. Clustered index, that phone book, is a clustered index. The data is the index. The book's back there. The data is the book. And the index is that little piece at the end, that thin piece at the end. Okay? So here's the structure. Again, we've got the root at the top and the leaves at the bottom. The non-leaf level contains the key. So whatever the key is. For those books, it's a keyword, a word that's in the book. I don't know how they come up with it. I was looking in my beginning T-SQL book this weekend, and I wanted to find something. I can't remember what it was, but a really common term, and it wasn't in the index, and I couldn't believe it. I think it was temp table. I was trying to find temp table in the index, and it wasn't there, and you got to be kidding me. Somebody else does the indexing. But anyway, in the top of the index are the keys. In the bottom of the index, the keys are repeated, so that the keys are repeated in the bottom. Any included columns, any special bits of information, like how many pages or what the publisher's name was, any those bonus columns go in the bottom. And also, guess what? The cluster key goes in the bottom. So that's the address on how to find, either if it's a heap it's pointing to, because we can have these on heaps as well. It's a thing called a RID. I can't remember what, something ID. Can't remember what that stands for. You remember what it stands for? RID?
Row ID.
Row ID? Okay, that's so simple. Why didn't I remember that? Row ID. So in the very bottom, it has the information on how to find the row in the table. So there's a lot going on in a non-clustered index. Okay, the other thing that's important is column order. I'm gonna even though a phone book is a clustered index, this particular example still applies. Okay, so you went to a party last night and you met somebody with the last name of Smith. And there's a lot of Smiths in the phone book, but let's just say that. And maybe Bob Smith. So how long would it take you to find the Bob Smith in the phone book? It'd be pretty fast, right? Because you know that last name. And you can just jump right to the Smiths. You can zero in pretty quickly, okay? What if you met somebody last night and all you found out was his name was Bob? How helpful would that phone book be? So this is an example of how column order in an index is important. Just because I have a key in an index, if I'm doing that key is in second or later place, I'm not going to be able to find it very quickly. So if I wanted to find all the Bobs in the phone book, I would have to look through every name in the phone book, and save that information. SQL Server does the same thing. So if I had a table and I had a non-clustered index on last name, first name, and I did a search on first name, SQL Server would have to scan that entire index to find all the people with that first name. So that's not as bad as scanning the table. But if I had the last name, SQL Server could jump right to that group of names. So the column order is important whenever we're looking at non-clustered indexes. Okay, so I've kind of talked about this already, those key lookups. I just wanted to make sure I had this picture in here because I love those card catalogs. So really the point is, if in a situation where you can't change the indexes, so there's an example I had years ago where we had a document management system. And in document management system, like for a law firm, there's a table that records everything that's done with a document. Not the changes, but this attorney created the document, and then there's another log row that says this secretary printed the document, this paralegal made a change in the document, on and on. That's all logged. You can imagine how big that table is. So what was happening is we were trying to figure out if a new indexing system would be beneficial for this. They were trying to put this in SharePoint and do all kinds of crazy things. But anyway, what ended up happening was this team wrote this query right against that log table, joined it to maybe a dozen other tables, and guess what? And then they had a filter to look for the last hour's worth of work. So they were going to run this every hour and re-index the documents. All they really wanted was, they wanted this information, but they wanted the last hour's worth of documents. So they had this crazy, crazy query. And it was so they had a timeout of 10 minutes, and it was timing out. So what I ended up doing, and temp tables are really beyond the scope of this, but I was able to take advantage of the indexes that were in place to solve this problem and get them the information they needed in 10 seconds, not 10 minutes. Because there was an index on the date that the document was touched. And I could use that to find the furthest, I could say, okay, well, let me find out the log ID number for an hour ago. Or I could even go back an hour and 10 minutes. And it didn't matter if we indexed a document multiple times, So I could do that and grab that ID. Then what I did, way beyond the scope of this, but I created a temp table. I just did every single column in that table based on that ID number, that primary key, that cluster key. So now I had a temp table. I had a little picture of those rows. Now I could take that little bit of information. Maybe it was 1,000 rows instead of 10 million rows, and then do my joins. So I didn't create any new indexes. I didn't modify any indexes. All I did was take advantage of the indexes that were there. I looked and I looked at them and said, look at this. And the reason there was an index on that date is because for the history, you could look at the history of a document. So that's partly why there was that. So, that's one of the things. I've done some manipulation on data just by saying, hey, for example, there's a customer I've worked with where they have multi-tenant database with lots of customer data in the same database. And these customers come in through the web and, they have their application. And every query has site ID, every single query. And so they'd have these queries that were timing out. And these things were monsters. They'd have in the same query a common table expression, a union, and nested subqueries, all in the same thing. Monsters. But what I would find, I would say, look at this common table expression. Inside this common table expression, they're not filtering for site ID. They're filtering in the outer query, but not the inner query. And I'd say, I wonder if there's an index on site ID. Sure enough, every single table has one. And, what columns, maybe we can make this work by an existing index. Well, I'm lucky in that customer because I can put in requests for index changes. But just by looking at what we have and saying, hey, wait a minute, why aren't we filtering on this? There's quite a few of them. All I had to do was say, hey, wait a minute, let's filter on site ID, get it to use this index right here instead of doing a key lookup with what it's doing, or instead of doing a clustered index scan. So, and like I said, the term covering index, that just means this index is a covering index for this particular query, not for everything. There's not a switch, there's not a checkbox. Okay, so let's just take a look at some examples. Let's go to AdventureWorks. You know what I realized last week? I work for AdventureWorks. So for those of you who don't know, AdventureWorks is, I'm sure, I know all my coder girls know because I've been doing demos with AdventureWorks for them. I realized the other day that the database that I'm in most often is AdventureWorks because I'm constantly doing a presentation or teaching somebody something. So I realized that I work for them. I write reports for them, evidently. Okay, so I'm going to just create a... Okay, I'm creating a copy of sales order detail. Hopefully this won't take long. There it goes. Okay, I'm going to turn on my favorite tool, Statistics.io, and I'm also going to turn on what's called an execution plan. So an execution plan lets me see a picture of what SQL Server's doing under the hood. And I hope this all works because I think I tested it before tonight, but maybe I didn't. Okay, so I'm looking at the product table. Oh, I'm looking at the sales detail table, but I'm filtering by product. And if I look at this execution plan, see it says clustered index, so I'm looking at the actual table itself, and notice this word scan. That means I had to look at every single row in that table to see if product ID was equal to 919. Okay, so that I don't like, when I'm tuning queries, I do not like seeing that unless it's a really tiny table. It's not always bad, but a lot of times it is. Okay, so was there a query? I'm surprised there was not a query suggestion. A lot of times what SQL will do is give you a little suggestion here in yellow.
Non-clustered index mostly.
Right, always for a non-clustered index. Here's the problem. Huh?
It always has your cover columns in it.
Right.
A lot of the times.
Right.
Clustering with the cover.
Right, so what happens is that people will see that and they'll say, oh, we need this index, without looking to see what's already there. So another thing that I do is I go into customers and I clean up their indexes because they have indexes that are almost duplicate or exact duplicate. That's another thing I do. Okay, so I'm surprised there's not a suggestion there. Okay, but I'm going to go ahead and add an index, a non-clustered index on that key. And we'll see if this helps. In this particular table, sales order ID is the cluster key. So now when I look at this execution plan, now it's using the non-clustered index. You can see non-cluster right there. And it's also doing an index seek. So now it's just jumping down the index to find the right rows. Let's look at, I should have looked at the logical reads before, and I didn't. But now there's only two. I can't remember. I should have looked at it, and I did not. But I'm just going to skip that. Okay, but remember that there were two for this guy. Okay, here is a similar query, but I added order quantity. So here's the thing. If any of you are using like select star for all your queries, that's fine if you're just trying to figure something out. Better to do select top 10 star. If you're returning columns that you don't need, you might be missing out on using an index that could be beneficial. Okay? So don't do that. Plus, people will laugh at you. You have somebody experienced see your code, they will laugh at you. You don't want that. Okay, so let's take a look at the execution plan. Oh my gosh, what happened? Before I had just a nice little index seek. Another thing about these, it tells you the relative cost. So now all of a sudden, 94% of my time is spent going to the bookshelf, going to the table. Okay? That's because order quantity is not in that non-clustered index. So let's run another one. Let's see how many rows this guy returned. Returned 16 rows and 50 logical reads. So before it was 2 logical reads. So we've got to do a lot more work. Even though these are still tiny numbers, this is tiny data. Really little data we're working with. Okay, let's see what happens if we change this value to a different product. Now I've got 3,000 rows. So before, I was making 16 shelves to the bookshelf. Okay? So now let's see what SQL decided to do. Guess what? Oh, here's my missing index hint. Okay. Now SQL Server says, I give up. I am not going to make 3,000 trips back and forth between the non-clustered and clustered index. I guess under the covers, it's not really making trips back and forth, but you got the idea. So it just says, I give up. I'm just going to scan the whole table. That would be more efficient in this case. And also, I've got it, one of those, I was thinking it was yellow. It's green. I've got one of these index hints. So let me just go ahead and look at it. Show missing index details. So what it's telling me is I need an index on product ID, and I need to include, remember that include things, those freebie things, sales order ID, but guess what? That's already part of the clustered index, so I don't need it, and order quantity. So that's that piece I was missing. But guess what? If I just create this, now I have one index on product ID, and I have another index with product ID and include order quantity. So you know what? That keeps me, keep doing it. Keep doing it, because you can then hire me and I can come and fix it for you. So keep doing it. No, I don't want you to do it. I don't want you to. But it's not unusual for companies, especially if they don't have a full-time DBA on hand, to just automatically take all this advice over and over and over. I've seen tables with, I don't know, 20 indexes on it. So you might be thinking, well, who cares? These indexes are great. They make things work better. But you know what? Every time I update my table, I've got to update my index too to keep it up to date. So you're going to get a performance hit. I have actually seen a situation where there were so many indexes on a table that SQL Server couldn't figure out what to do. Yeah, SQL Server could not figure out what to do. If you ran the query would take forever. If you went into this particular table that had like 20 indexes and deleted a few of them, the query would run faster. I am not kidding. It actually happened. One of my customers at Pragmatic Works.
I'm sure they haven't given you the examples from our class this week yet, right, of the queries and stuff?
We've been talking about them and looking a little bit.
There are quite a few tables that have large number of indexes.
But that's coming from the vendor, right?
Right. We have it's a vendor package. They don't want to remove the indexes because they figure, well, maybe down the road somebody will need a query which will need the index, and then they have to go out and get it.
I should go up to is it Wisconsin where they are? I keep all your people.
Oh yeah.
You're telling me about their cool campus up in Madison. So I think that maybe we need to make a trip up there. But they're working with hand in hand with Microsoft, like the Technology Center. You know, aren't they working hand in hand with them? You think that they would give them some help?
It was originally ported over from a month's database. It is not truly relational. There are some tables which have implied meaning. They do not use foreign keys. But
That's
they sure
pretty
do-
normal.
But they sure do throw a lot of indexes, so
They
when the data loads, you know,
Mm-hmm.
and people say, hey, Morale here, he says, I need a custom index, it's like, I've already got 20, you gotta get this blessed off, because it will slow the insert and the load processing.
Right. Yeah, it seems to me like it'd be worth going ahead and just scripting all their indexes out and just going ahead and doing some index tuning, and then when you have your upgrade, then revisit that again. But I don't know, what were you going to say, Clayton? Or are you just going to agree with me?
I was going to say Yogini.
What?
You aren't going to need it.
We aren't going to need those indexes.
Yeah, I mean, if you need it in the future, you need it in the future. Determine that then. But
Exactly.
Well,
That's just float.
and what he mentioned
Exactly.
is, SP Blitz.
Yeah, Brent
Brent
Ozar
Ozar's.
is SP Blitz Index
Mm-hmm.
is a godsend.
'Cause it tells you.
It'll tell you, yeah.
I've played a little bit with Brent Ozar's thing. I haven't really used it that much, but
I think
just
if
play
you
around with
do
it.
that and store it into a table, because every time your server's rebooted, you'll lose the history. So if it could be that you have a report that's run quarterly that needs that index.
in that case, that's where that art comes in. You've got to know. You got to know. So when I do index tuning, I don't ever completely get rid of anything. What I do is I say, oh, these two are duplicates, and this one's got the keys are the same, but they have different included columns. I'll combine them, but I try not to remove anything completely because I don't know if they have a month-in process.
Question on the included columns. I'll show my ignorance openly because that's how you learn. So I have the column that's the index column. Then I have the included column.
Right.
There's no implied order to those, is there?
The included columns, no.
So it can bookmark and look up against any of those based on the primary.
No, it doesn't look up any of the included.
It doesn't have to look up. So he meant pull them out of the non-cluster.
Yeah.
Right. And you can actually do even wheres against those, but then you're going to scan your index instead of a seek. Okay, let's do this one last thing. So what I'm going to do as a database professional is I'm not going to blindly accept that information. I'm going to take a look at the indexes and say, oh, there's already one in product ID. Why don't I just recreate that with that included column? So here's what I'm doing. I'm just going to drop it and recreate it with a new definition. Okay? And before, let's look at what the query was we ran before, 707. So this is the one that was a scan. And so now, when I run this one, fingers crossed here, now it's a seek again. So I was able to take that query that in the production they were timing out. I got rid of that key lookup. So that's one of the things I really look for when I'm tuning queries. One of the things I zero in on is key lookups and clustered index scans. I think, let me go over, I got more demos here than I can actually talk about. So I think what I'm going to do is just talk about some best practices and finish up, okay? Hopefully everybody learned something tonight. Maybe they learned that I'm a little nuts. Or I'm a geek. They learned that I'm actually a nerd. They may have learned that. They may know of everything else. All right, so some of the things on what do I index? I need to index foreign keys. Why do I need to do that? Because I'm joining on foreign keys to a primary key table. The other thing I'm doing is when I do inserts, every time I do an insert, SQL's got to go look at that other table to see if, let's see, am I thinking that right? Foreign key, because it's got to look to see if it's correct, if you can add that row. I think I've got that right. Avoid duplicate indexes, okay? Because they're taking overhead. They're not really helping you if you have these duplicates. What I mean by duplicates is usually I figure it's a duplicate. Like the first two columns are the same. The next two columns are the same. Like that. If I have an index, if I don't have a ton of indexes, and I have the first column is the same, but the second columns are different, I'm going to assume there's a business reason for that. I'm not going to get rid of that. What I see over and over and over is, and I did some index cleanup last week for a customer, where there might be 4 indexes, and every single one is the same exact key, but different included columns. I know how they figured those out. It's because they either did that right click like I just showed you on that advice, or they use it. There's also a tool called Database Tuning Advisor. Don't use that. Or if you do use it, pay attention. Make sure you understand. You're saying don't use it. I had to come up with a demo of it one time for a Pragmatic Works class, and I'm like, are you kidding me? But even if you do use it, make sure that you think about every index. Don't just blindly add them. Okay, avoid indexes that are rarely used unless there's a business reason. So we can actually run a metadata query in SQL Server and see if an index has been used since the last time SQL was restarted. But the problem is, I do not just delete indexes from customers because I don't understand 100% of their business. There might be an index in place that runs a report at the end of the month, and without that index, maybe that hour-long process is going to take 3 days. So I'd be very careful about, personally don't delete stuff. And do not blindly follow recommendations, okay, from SQL Server. From people maybe, but not SQL Server. Because it's just, I don't know, it's a program. It's a program. It is not smart. It does things fast. People are smart. All right, I'm going to skip that. But I wanted to bring these resources up. There is a guy named Glenn Berry. He's wonderful. All these metadata queries that are really confusing and hard to understand, he's got scripts out there, and he's got scripts to look for indexes that SQL Server suggests. So one thing I do, I run this missing index query, and I find indexes that might be useful. But again, I don't just blindly follow it. I see what else is there. He's got scripts for, how often indexes were used. He doesn't have the duplicates, but I believe at the very bottom, the duplicate script. Jason Straight, Expert Performance Indexing for SQL Server. Really, really great book. I think it's probably the only book out there on indexing for SQL Server. And there's also a really great guy. Oh, I should have put the picture. I saw him at a SQL Saturday, and I got my picture with him. He was like the rock star at that SQL Saturday. Ola Hallegren is a guy that wrote some really, really good maintenance scripts. Instead of using the little wizard that comes with SQL Server to create maintenance, you can run this guy's scripts, and like everybody loves him.
It's free.
And it's free. He should charge, but he does not. But anyway, that is all I have. So I hope that everybody had a good time. I sure did. And thank you very much.